Hello everyone. Welcome back on our YouTube channel. I hope you've seen some of our previous videos on this channel, and I hope you like them. In case you're new to our channel, we are regularly posting content about Postgres here, which we found useful for many of our clients and customers. Today on the list, it's the topic which is on the list today. It's really close to my heart because I've seen it so often when we went out doing consultancy, performance tuning, and stuff like that. I've seen so many left joins in my life, which were just plain wrong, right? So that I decided to create a brief video on this entire topic of outer joins, etc. And I hope that we can avoid some of the common pitfalls people are facing in the real world by just sharing some of this information with you guys out on the channel. But before we get started with left joins, let me just introduce myself and my company. My name is Hans-Jürgen Schönig. I've been in professional Postgres and database support for 20 plus years. My company is providing Postgres-related service, consultancy, support, clustering for customers all around the world. So as you can see, we've got a couple of offices worldwide, which means Uruguay, South Africa, Mauritius, Austria, Switzerland, Poland, and Estonia, with more locations to come. So we are highly specialized on Postgres. So if you got anything related to Postgres, just get in touch with us, and we should be able to help you a very professional way. So left joins, common mistakes. As I've stated before, this is a topic which is very close to my heart. I've seen it too often, so please take it seriously because it might avoid some really nasty issues in your application. So let's get started. Often outer joins are used in the wrong way, okay? And because data sets are usually large, people are not aware of the fact that their joins are wrong, right? They return an answer. It looks reasonable, but it's basically wrong, okay? So let's dive in and figure out why. As always, let's prepare some sample data. So I've created a table here. I just called it A, and it contains 3 values. So generate series, it's going to return 1, 2, 3, and we call it AID. And then there is a second table, which I just called B, and it's going to contain 2, 3, 4. So if we look at the data, super sophisticated data set, it's going to be 1, 2, 3, 2, 3, 4. So as you can see, it's not exactly the same, but there is a little bit of intersection here. If we run an inner join, what we're gonna get is the intersection. So if we do from A comma B, where AID is BID, what we get is 2, 2, 3, 3. So we get the intersections because the keys have to be present in both values. Some people keep asking in Postgres if there's a difference between from A comma B where and from A join B on. In this case, there's absolutely no difference. So up to a certain number of tables, the Postgres optimizer is going to behave exactly the same way. So for practical reasons, for reasonably complex SQL statements, it's the same thing. So implicit and explicit basically does the same thing, unless you're going beyond, I think, 8 tables or something, okay? So that's an inner join. It's going to give us the intersection. But sometimes we don't want the intersection. So if you look at the first query here, it says, select star from A left join B on AID equals BID. Super important here is that in case of a left join, we get everything from A and we get the values from B which match the on condition. And everything else is just going to be null, okay? So in this case, everything from A means 1, 2, 3, and everything that matches the on condition, so meaning A equals B, which of course means 2 and 3. So what we see here is 3 rows. That's a common problem here. So if you look at the second example, very often people add a where clause. And what the where clause does is it brutally filters out everything, rendering the left join pointless. Okay, so if you have a where condition, make sure that it's going to filter data, and it's going to filter away the data created by your joins. Okay, so this is a very common misconception here, that somehow miraculously this where clause is going to do something very nice for you. Well, it does, but maybe it's going to destroy your left join. And in this case, it's just going to be a bug. Okay, so be careful with this where stuff and on stuff. I got to show you in detail what it means here. So this, what you see here is the most common bug ever in case of outer joins. So we do select star from A, left join B. That's absolutely clear. But in the on condition, what we do is A equals B. We've seen that before. And often people are going to add an additional restriction, assuming that this is going to reduce the amount of data you're going to get. It does not. What the left join means is that you will always get everything from the left, and from the right side, you're going to get the rows which are going to match the on condition. So in this case, AID has to be BID, but we only match if AID equals 2. So we're still going to get 3 rows, everything from the left, but only the number of rows that match are going to be lower. Okay, so in this case, we still get 3 rows, but we only get 1 match. To make it more clear, clearer, the second example does the same thing, but in this case, we do AID equals 5. So we got no match. We still get everything from the left, but on the right side, there is no match, but it's still going to be 3 rows. That's super important, because often a broken left join is going to be reported to our support team as a performance problem, right? So if A contains 100 million rows, and you're going to do some fancy magic there, it's going to be slow. And people are wondering, why is Postgres not using this bloody index on AID? It should only be 1 row, right? No, it's not. You're going to get 100 million rows. And obviously, there's no index here because you need all the data, right? There's no point, okay? So often, those broken left joins are reported as performance problems, which they are not, okay? That's super important. So if you got an on clause containing an end condition and something that looks like a filter, which is AID equals 5 or so, think about it twice, because it might be a bug and you might not get the answer you expect. Okay, so that I've seen that hundreds of times, literally. The same is true for a full join. So in case of a left join, you get everything from the left and everything that matches on the right. In case of a full join, you get everything from both sides. So on the left-hand side, it's going to be 1, 2, 3. On the right-hand side, it's going to be 2, 3, 4. And Postgres is going to connect the data in a way that you see the intersection and you see everything that's on the left and everything that's on the right. But. Let's again add an AND clause to the scenario. In this case, we're going to get 6 rows, because everything on the left doesn't match anything on the right, because BID is never going to be 10. But the concept of a full join is you get all the rows from the left, all the rows from the right. And if they don't match, it's simply going to expand. Okay, it's going to be more and more and more. And that's what people usually don't expect. Okay, so they expect this to be empty or whatever, right? But nobody usually knows that it's gonna return 6 rows. So be very careful. The concept is the same as you would get with left joins and end conditions, but in this case, it's simply a bit more weird. So you have to wrap your head around it, and it's gonna be 6 rows and not 3, and certainly not 0. Okay, so very common mistake. I was referring to subtle errors before. In case of a left join, what you often see is that people select everything from the left, then they're going to do some magic joining, and then they're going to put some aggregate on top. be very careful what you wish for. Count star counts everything. Okay, so count star says count all the rows. So it's going to be 3 rows. We don't care if it's null. We don't care if it's whatever. So if we count star, it's going to be 3 rows. If we count AID, it's going to be 3 rows. But if we count on BID, it's only going to be 1 row. So be very careful with count star because it's going to count all the null values, which are obviously injected by the left join. So if you see a left join or a full join with count star, be careful because most likely you might only want to have count column instead of count star. Okay, there is a world beyond count star. Okay, there is more. There's a difference between count star and count column, and the reason is the null values. Okay, so this is a very common mistake. And especially if you do average and stuff like that, it might be slightly off. Okay, so it looks correct, but it's not. Okay, so be very careful here. So finally, what you've seen here is not Postgres specific. It's absolutely ANSI SQL compatible behavior. So it's absolutely desired behavior. And you should be very careful where to put your filters. If you put it in the on clause, it's simply going to restrict the matches. If you put it into the where clause, it's going to filter away the data. Okay, super important thing. So finally, thank you for your attention. So if you found this topic interesting, please share it, subscribe to our channel, tell your friends, maybe put out a Twitter message, follow us on Twitter, follow us on Facebook, subscribe to the channel, and hopefully leave some feedback in the comment section. And I'm looking forward to seeing you again. So have a nice day and make sure that your left joins are 100% correct.